So DAWN is a protocol for providing decentralized broadband, and you're going to get to a good chance to see what that means in a second. But if I want to walk you guys through the problem statement, why am I even working on this in the first place? I guess it all really started with the fact that I was getting screwed over by Comcast one too many times, and I wanted to do something about it. But to give you a sense of how this same problem that I felt is really representative all across the world, this one stat over here kind of boggles my mind that only 50% of Americans have option to one high-speed internet provider, right? So consumers don't really have a choice when it comes to internet or anything else in this vicinity of being able to offer a high-speed connection to people's homes. So it's almost a little bit reductive for me to repeat this problem to you. If you are in crypto, you understand this entire consolidation problem has gone a bit too far. And I think it's fascinating to look a little bit at the history of how something like this manifests, right? How do we get to a point where we have an oligopoly across all of these different industries, across this specific industry at least? And the history behind it, actually, it kind of makes a lot of sense. The only way that we've had to be able to deliver connectivity over the past several years is to run wires into people's homes. And lately, things have upgraded to fiber optic technology, but we're still in a scenario where it costs over $1,000 to be able to just cover a home and provide some level of nominal service. And if you're in a scenario where you have to spend $1,100 per home, that's naturally going to lead to a level of consolidation, but more importantly, it's going to prevent upstarts from being able to actually compete in this space. And so the argument that I make as I've looked at how wireless has evolved and as we kind of consider a world where we eventually go to a fully wireless one, it's clear that when you look at the unit economics of providing coverage and service using wireless, it's just much better. If you're in a scenario where you can cover a home for $10 to $15 rather than thousands of dollars, that actually really represents a way forward. And that's the essence of the opportunity that we started taking advantage of in 2018. We saw, hey, if you could find a way to get wholesale bandwidth that you could bring to consumers, and then pair that with good technology, good wireless technology to make it very cost effective, you could actually start competing against these guys. So Andrina is a Web 2 company that I started off in 2017. We built a wireless network with Princeton University and then started branching that off to a whole bunch of other areas. But the essence of how that is all done comes down to these 3 points that are over here. The very first thing you got to do is you have to buy affordable internet. You're typically going to data centers, wholesale internet providers, and more. And to give you a sense, that 50 cents per month, that is essentially what it costs to buy a residential internet plan directly at a data center. So I currently, where I live, I have Verizon. I pay $128 for Verizon. And in that scenario, if it only costs them 50 cents at a data center. So if you can leverage that incredible margin and just keep and find a cheap way to distribute it from point A to point B, then you have an interesting business. And so that's really where points 2 and points 3 come in. If you can then take it from that data center, beam it over the air using wireless radios and antennas, and then on point 3, distribute it directly to the consumer, now you actually have a much lower CapEx way to deliver internet to people's homes. And to give you guys a sense of how a small little company like ours can make pretty decent progress, this is like a decently good status update about what we've done with this. So we started a Web 2 business that competed directly against Comcast and Verizon. We're providing internet to over 10,000 households right now, and we're operating in now 11 states. So to give you a sense, we've worked with real estate partners, we worked with the New York City Housing Authority, the Jersey City Housing Authority, all the way up to Class A developers. And this just gives you a little bit of a sense of what a small company can do with a little bit of capital and a really good team behind it. But we are able to build a coverage map of 1.5 million households in the northern New Jersey, New York area. And so this is really something that if you can scale this all across the world, it's what it's actually needed for wireless to be able to provide a competitive service towards fiber. And through the process of building this network and going to about these 11 states that we have here, we built a lot of the technology that made our lives easier, like to kind of be a little bit more concrete. We built the technology that allowed us to automate various aspects of internet delivery. And in that process, we kind of realized that, hey, if you could find a way to actually have the consumer help you, to have the consumer work with you to build mini Andrinas all across the world, then you can actually scale this entire vision much, much faster. And that is the essence of what Dawn is. We've taken a bunch of this technology that allows us to do our jobs well, and we want to enlist the consumer in helping us build a consumer user-powered wireless network. And there's three major hallmarks of what a network like this actually looks like, but it all kind of starts with this first point over here. When you are essentially using wireless and you're teaming up with households to be able to distribute this across an area, you're essentially fractionalizing the CapEx. So not only does wireless give you a whole much cheaper cost to cover, but then you're spreading it out across many different homes to reduce the barrier to entry. So you can allow everybody to participate in that infrastructure. The second major point here is you're in a scenario when you have a user-powered last mile network. There is no centralized provider. People are able to offer internet directly to each other. They can set their own rates, and hopefully that nets out for better price discovery, and the market will converge to a better, cheaper internet solution for everybody. And the way that we see it happening is that if you remember back to that previous slide, when you're buying internet at 50 cents and the consumer's bringing their own hardware, there's no reason that a gigabit internet can't cost $10 to $30 per month. And if you're in a scenario where you're paying, like me, 128, and you're now going to 10 to 30, you're in a scenario where you can allow consumers the ability to really save thousands of dollars a year. And this is essentially why we get so excited by this vision, right? I don't think a lot of other DePIN projects have the ability to be able to have that level of a direct monetary impact into people's homes. And my hope is that with something like this, it can accelerate the transition of bringing DePIN to individual households. So the last most important thing that we need to cover here before we get into some of our progress updates is that if you care at all about the space of connectivity and the history, I originally thought telecom was boring, but I started looking at stuff like this and I thought it was a little bit more fun. But the point being is that this vision of what I'm pitching here of a user-powered internet, it's one that is important to keep in mind that it's been around for the past 20 years. You've had researchers in MIT were the first guys that really tried to take this vision and make it practical. And it starts with this project in 2003 called RoofNet. And RoofNet was essentially a scenario where you had a bunch of different students that used their dorms to create a wireless mesh network using 900 megahertz spectrum, the same that Helium used on their IoT network, to be able to interconnect this network and essentially deliver gateway from all the way on the top of the network directly to those DSL points down over there. And so they were able to demonstrate that you could definitely do something like this, but the reason why this didn't become the norm is because of this first point over here, is the technology at the time from a wireless perspective was not good enough to be able to offer a meaningful home internet service. And in this scenario, they were able to deliver about 0.5 megabit per second of throughput, but that's nowhere near where you need to be able to deliver high levels of speed. But 2023 and 2024 were really the first years when wireless technology got to a point where you can actually offer multi-gigabit levels of speed, right? The other major successful technologies out there like 5G home internet, Starlink, even those can't offer multi-gigabit levels of speed. So fixed wireless is kind of the first time that we as a society have taken wireless to the point where we can compete against fiber. And when you look at sort of these other things that I mentioned, wholesale internet for a gigabit costing around 50 cents per month, you can really begin to see how it's very easy to bridge that gap now from people that have excess bandwidth all the way to the people that want that bandwidth. And I think when you consider also the fact that a single Zoom call only uses 0.5% of your total supply, consumers have a lot of data to be able to service and bring to other people. And so before we kind of go on to some of the more other updates that we have and the technology behind it, the easiest way you can think about this is if you think about how Helium provides decentralized mobile service, our aim is to provide decentralized fixed service, so internet for homes and for businesses. And to give you a sense of some of the technology that's behind this, some of you hopefully have seen some of this stuff that we've been talking about online, but these are the kind of three major categories that we felt that we had to innovate on at Andrina that now create the backbone of what allows a consumer to actually participate in this network. So the first one that we have, and we built out this system called the robotic antenna system. It essentially takes a generic antenna and a radio and adds a mechatronic system to be able to automatically aim it and point it. A good example of why this is necessary is when you buy a Starlink connection, that dish will point itself at the sky and align itself with the LEO constellation above you. It's the same idea here, except you're going to have to connect to somebody else who's in the vicinity that has extra bandwidth to give. The second piece of that is we noticed that through the commoditization of Wi-Fi baseband chips from companies like Qualcomm and MediaTek, it actually became very easy to build your own Wi-Fi AP. And by actually owning this piece of it, not only can we make enterprise Wi-Fi cheaper than pretty much any other company out there, because that's not really our business model. We can kind of pass the savings on to other folks. Well, we can build custom firmware that allows us to do very easy internet sharing. So if you're in a scenario where you want to share your internet with their neighbor and have it all encrypted, stuff like this is what allows you to do it for very cheap. The third one is, one that I'm quite fond of, is this generic purpose router. So we also built this, we took technology from Cisco in 2021 that was open sourced and built a software router on a generic x86 machine. And what that means is that instead of buying an expensive Juniper or Cisco device, you could now do multi-gigabit routing on a $200 to $300 device. And so the barrier to entry to be able to provide high performance routing, which is what you need for a user powered network, has been taken down massively. Now there's a lot of fun other things that come with this generic purpose router. It can be a multi-miner. It can do stuff like, Akash, render, Filecoin. There's a lot of cool things that you get from having this little black box in people's homes, but just important for now, just to keep that level of performance in mind. So I don't want to spend too much time on this slide, but here are some fun updates that we've got over here. We announced our fundraise about a month ago, and since then, we've got 500,000 verified users that downloaded our Chrome extension, which is essentially a verifier in the system. So I think what's gets me quite excited about this is the very same vision that Helium brought to the table that got people excited about a user-powered internet. It's still alive in people, and the traction that we have received from this, I think, is just a resurgence of that same phenomena that we've seen in consumers. And in terms of on-chain revenue that we've been able to bring on from the Web 2 business, obviously that speaks very strong for a very important topic in DePIN right now, which is the demand side. And I'm very confident in saying that we have de-risked a lot of that demand because everybody needs internet and people love saving money on their internet bill. So hopefully we get to take this to the next level. And even though Andrina has historically been a Web 2 company that's operated in the United States, I also want to impress on the fact that this technology is really designed to operate internationally. The major unlock that kind of allows us from a wireless side was the FCC releasing 6 gigahertz of spectrum that the rest of the world has since followed suit. And the last time this amount of spectrum was released, it led to the creation of Wi-Fi and Bluetooth. So frequency is, in some scenarios, a proxy for technology and economic value that can accrue in connectivity. And so as we see areas that have good wholesale infrastructure, right? If you look at Ghana, there's a massive amount of subsea fiber optic cables that run from London all the way down to South Africa. So you're in a scenario where if you can tap into a couple of points there, you can really build a highly performant network that is just much cheaper than fiber. So we're excited to bring this technology all across the world. We're obviously going to be deploying in the US, but we have operators that are in these 3 countries that are excited to partner with us and be able to deploy here as well. And before I kick it off to any questions, this is kind of, the final mental model I want to leave you guys. If you want to ever explain to somebody what DAWN is, obviously you have the Helium mental model to be able to understand, hey, they're doing mobile, we're doing broadband. But I think this entire trend kind of falls into something like this a little bit more, where our goal is to do to internet what solar panels have done to electricity. The same way that solar panels give you consumer-owned infrastructure, you get access to a cheap and abundant resource, and you can sell your surplus back to the grid. We're now looking to do the same thing with DAWN in a connectivity perspective. So the same way solar panels give you energy independence, my hope is that a protocol like DAWN, and namely DAWN itself, is going to be one that brings connectivity independence to folks all across the world. So if you guys want to connect to learn more, you guys can obviously hit me up. I'm going to be here for a little bit. Hit me up on Telegram, Twitter, all that good stuff. We're always looking for folks to be able to deploy with. If you have a good community that you want to set up a bunch of nodes in and be able to earn some money by selling internet to others, let us know. We're more than excited to team up. But that's all I got for you guys. If you guys have any questions, I guess now would be a good time for me to take them.
Any questions? Looks like everyone understands every element of the protocol. Oh, we got a question from Mike.
Second one, Mike.
It's going to be a good question. We know that.
Not sure about that, but what's your plan on a token and how are you going to accrue value to the token?
Yeah, so the plan for the token is there's a lot of different elements towards that. The part that I'll say right now is that the same way that a token is in any DePIN project, like as a GeoNet, right, is that you need to incentivize the creation of supply. So the protocol will essentially emit tokens where people deploy nodes that is proportional to the value of the supply. So a simple example of that is like in traditional telecom, the major metric people look for wireless coverage is households passed, right? How many households you serve. So the protocol will emit tokens that is proportional to the amount of households that are served. And hopefully technologies like GeoNet actually play a role in helping to localize that and verify the amount of coverage that people have. The second piece of it, which really didn't get into in this presentation, is it helps add a trustless layer. So if I'm in a scenario where I'm selling you a gigabit of bandwidth, how do you really know that I have a gigabit of bandwidth to sell you? And so there's some interesting proofs that we've built on top of this with a company called Witness Chain, like proof of bandwidth, which gives you a decentralized speed test. And a token is essentially a store of economic value that can be slashed in a scenario where people don't abide by the stated topology of the network and the performance they're supposed to offer. So there's a whole lot more things on the token side of stuff. White paper's got a bunch of details there, but hopefully that gives a little bit of a primer. Yeah, for sure.
How interested are you in rural deployments?
So I'd say in developing countries that have rural deployments that have some level of density to them, we are interested in those. Typically, I see like areas that are like actually properly sparse, not necessarily a target for us. Like we were mostly interested in urban, but then we got approached by a company that is essentially an impact fund that does DePIN projects in emerging markets. And they were saying, hey, if we could find a dense community in Kenya where we can deploy a Starlink at the school, but not everybody else can afford a Starlink, can we actually use Dawn to distribute it terrestrially? And it ends up taking that connection and spreading it out. So stuff like that, I'd say, is probably the way that we think about the rural side of stuff. But I'd imagine most of the growth is going to happen in the urban footprint.
How much can you spread it out? How easy is it to spread out?
So the most important thing in this like multi-gigabit scenario, the constraint is line of sight. So you're in a scenario where you can typically offer point to multi-point multi-gigabit service in the range of around 3 to 4 miles. So it depends on things like weather and all that kind of stuff, but it is pretty far, right? Like we have one site in Brooklyn that's the tallest building in Brooklyn that can see over 1 million households just from its footprint in that 3 or 4 mile radius. So a single node, a single right person can really create a lot of value for the community this way.
Great. Any more questions? All right, let's have a round of applause for Neil. Thank you, Neil.
Thank you.